Hello friends, welcome back to my channel. In this video, I will show you how to repair an AC inverter welding machine. It uses modern inverter technology, which convert main AC volt into DC, which is then inverted back to high ampere AC at high frequency. It has high efficiency and arc stability compared to old transformer type welding machines. And also it is very small in size. Let's connect the welding machine into the mains supply and check the issue. Mains indicator is on, and also the cooling fan is started running. On the front side we can see a yellow indication, which means the welding machine is in protection mode. There is no output from the welding machine, no arc is generated at the output. As I said earlier, the welding machine is in protection mode. In operation mode, we can see a green indication here. Let's disconnect the power supply and find out the issue. This is the inner part of this welding machine. Main input volt is coming from these cables, it is going to the interference capacitor, an EMF filter coil, an NTC thermistor, and a safety relay. Then the AC voltage is rectified by the bridge rectifier, which is located under these heatsink. The output from the bridge rectifier is going to the main filter capacitors. There are 3 capacitors are connected in parallel to smoothing AC to DC. This rectified DC voltage is going to the drain pins of the IGBT, which uses to drive the output transformer. There are several IGBTs connected in parallel to handle more current. Here we can see 2 pairs of IGBTs are used to drive the transformer. 2-switch forward technology is used here to drive the high-frequency transformer. The output of the transformer is connected to the Schottky diodes, which convert AC volt into DC. There are several diodes connected in parallel. At the output of the welding machine we get DC voltage. This is the SMPS section of this board, it generates 24 volts DC. It uses to drive the cooling fan. And also it provides supply voltage to power up the inverter module. This inverter module generates high-frequency signals, which is fed to the input of this 4 power MOSFETs, which are used to drive a high-frequency transformer. This transformer is located under the heatsink. It generates gate voltages for the IGBTs. First, we have to measure the output voltage. Put the multimeter into DC mode. there is no voltage at the output. Let's measure the input voltage of the transformer. Put the multimeter into AC mode. The input voltage of the transformer is 0. Seems to be the IGBTs are not working. Let's measure the gate voltage of the IGBTs. In order to check the gate voltage, connect the multimeter common lead to negative and positive lead to gate of the IGBTs. The gate voltage is very low, it should be minimum 5 volt. So here no gate voltage is generated. Now we have to check the inverter module section. Now let's turn off the mains voltage. We have to discharge the main filter capacitor in order to avoid electric shock. Now we have to check these 4 MOSFETs, which used to drive gate driver transformer. Put the multimeter into diode mode. Here I am checking for any short circuit on the MOSFET pins. In normal case, if we connect the multimeter red wire to drain pin of the MOSFET and black wire to source, we can see a value on the multimeter. If we charge the gate pin, that value will be reduced. It means that MOSFET is in good condition. In most cases, we cannot check the MOSFET on the PCB. For proper checking, we have to remove it from the PCB. There is no shorting found on the pins. Here we can see, one resistor is broken. This resistor is connected in series, with the 24 volts and a voltage regulator. It may be a fuse resistor, or maybe a current limiting resistor. This one is a L7815, 15 volt regulator. It used to regulate 24 volt to 15 volt to power up the inverter module. Let's check the fuse resistor and its associated components. There is no conductivity across the fuse resistor. There is conductivity in between ground and the output of the 15 volt regulator. The output of the voltage regulator is shorted. Let's measure the input and output voltages of the regulator. The SMPS output is 25 volts DC, which is going to the input of the 15-volt regulator through the fuse resistor. The input of the fuse resistor is 25 volts, the output voltage of the fuse resistor is 0, and also the output of the regulator is 0. Okay, now let's desolder the fuse resistor and regulator from the PCB. Fuse resistor is completely damaged. Also, we have to check the regulator IC. Before that, let's check the board. Still, there is a shorting on the board. Let's check the regulator IC. Regulator IC is in good condition. Now we need to find the short circuit on the board. Due to this short circuit, this resistor is damaged. Components that showing short circuit should be desoldered and checked. Now, I desolder the inverter card from the PCB, so I just want to confirm that, whether the shorting is on the inverter card or on the main board. Still, there is shorting on the main board. These two SMD capacitors are showing short circuit. Let's remove them from the board and check. I have checked all the SMD components in this part, and I didn't find any damaged ones. Now only this IC is left to check. And also some of the electrolytic capacitors are need to check. These two capacitors are showing short circuit. Let's remove them from the board and check it. Now the short is removed. This capacitor has the issue. Although it looks fine on the outside, it is damaged and shorted on the inside. Let's replace the old capacitor with good one. Now there is no short circuit at the output of the voltage regulator. Let's connect the mains input cable and see if the machine works. Now we can see that the welding machine's green indicator is on, and the yellow indicator is off. Now let's measure the output voltage of the welding machine. The output voltage of the machine is 60 volt DC. Seems to be it's working good. Now let's try to weld something. Welding machine is working good. Let's close the cover. Hope you liked the video. If you liked video, please subscribe to my channel. Thank you for watching.